Hello, welcome. This is Samuel Ambrose Onen. I'm just going to walk you through something very interesting concerning Java. So, Java is actually a very interesting programming language, and it is a language that I'm going to use to implement the model that I came up with last time. Design a model for the contextual and conceptual understanding of algorithm and how to solve a computational problem. And I implemented the model conceptually and contextually. Now I'm going to use Java programming language to implement the model practically so that we can understand how to use it, how to apply it with any kind of programming language that you may. The type of programming language you can use is not limited as long as you apply the right algorithm to solve the problem. So let us dive to the Java. But before we go deep into the insight of Java, to see the structure of Java, the philosophy of Java, and how we can use Java to add values, to the customers, let us try to look at why on earth do we need Java programming language. Yes, I know some of you may say, Java is heavy duty or Java is very hard to learn. But to be honest with you, Java is one of the programming languages that once you learn it, after that, learning any other programming languages will become more simpler than not learning Java before. So once you learn Java, it gives you a stepping stone where you can stand on and spring up with all other programming languages because it has a lot. Yeah, it's heavyweight because it has a lot of things, and of course, Java is a strongly typed language, and that makes it very interesting. We learned Java because Java is now being used by many machines around the world. According to Oracle, they say that over 3 billion devices are using Java application around the world. Although in my case, because I got exposed in Java right from 2004, and back then that statement was already there of 3 billion devices. So 20 years later, I think perhaps the number of devices using Java application could be more. you know I don't expect to see 3 billion all the time on the Oracle website. But that's my view. So why and how Java is a platform independent programming language? Well, Java is a platform independent programming language because you write it once and you run it on any platforms out there. So when we talk about platforms, we are talking about the operating systems and uh, some kind of processes out there, because as we know, different operating systems have different machine codes, and the same thing is with the processor. Different processor also have their machine instruction set. So note this difference, the machine code and the machine instruction set. So when we're talking about machine code, we refer to the software that the operating system used to interact with the hardware, with the processor, obviously. And then when we talk about the machine instruction set, we refer to the program that the processor can understand to execute the task given to it, whether it being arithmetic, operations, or data manipulation, or doing any other input and in and output operation requested or needed by the system. So that is the difference between the machine code and machine instruction set. So different operating systems have different machine code, and different hardware processors have different machine instruction set. And because of that, when you compile a program, for example, program like C++, you compile it directly to the machine code or machine language. But with Java, instead of compiling it straight to the machine language, you have to compile it to what is called the bytecode. And the bytecode is like the interpreter to interpret the human language to the machine language. But what actually make the mysteries occur, if you like, is what is called the Java virtual machine. Virtual machine comes with the runtime environment for running the Java. It is the one that converts the bytecode into the machine code. So that next time when you want to run Java again, as long as the machine has the Java virtual machine, you don't need to recompile it again. And that is the reason why they say you compile Java once and run it anywhere. So let us see how these things play about. Basically, we have what is called a human language, and Java is one of the languages that is written in the human format, like what you're seeing on the screen there. So that is the atomic Java application. So this is a program that just print BMW on the screen, but it contains everything that you need to know in order to learn Java. We have the class there, we have the access modifier there, we have the access identifier there, and we have the access specifier. So we are going to talk about all this in the next coming video. But from there, you can see the word public there. This public is the access modifier. This means that you can access this program from anywhere. It's accessible to the public. And the word class there is the access specifier. It specifies the group of codes, and that class is a keyword that is used to specify that group of code, and that group of code is defined by that car. That car is the identifier. So you can see we have the access modifier, access specifier, and the identifier of the program, and everything is enclosed inside the curly braces there. You see the beginning of the code and the end of the code must be enclosed by the corresponding braces. And inside there we have public static void main string args. So this is a method. It is like the entry door for the Java program to start running. Without this line, my friend, you won't be able to run Java application. So this is like the window, if you like, because the entry point of the program, Java begins from here. And this is saying that Java accepts an array of strings as input in order for it to start running. You see, so make sure you get this right. And then this is the, we are just printing something here. This system is a class. It's one of the classes in a Java package, which is the default class, because we don't need to import anything in order to call the method. So this class has a static method called out. We have another method called print ln. So this one gives us the output that we need, which is BMW. So when you run this program, it will give you BMW on the screen without the quotation. These quotations are the string literals that indicate that this BMW is a string. So that is just a brief overview of the atomic structure of Java application. But that's not the main aim of this video. This video is meant to show you why and how Java is a platform independent programming language. So let's see. As I said before, each platform of computer has its own machine code or machine code information set, if you like, because the combination of the two makes the mysteries happen. It makes the hardware and the operating system to communicate. So each and every computer has its machine code, which is the software that enable the operating system to communicate with the hardware. And then we also have what is known as the instruction set, which allows the processor to communicate with the operating system as well to get the information about what to do. For example, the processor may be waiting to do some kind of arithmetics or data manipulation, or you know inputting something or outputting something. So all those operations are determined by the instruction set. So each and every computer has its own machine code information set. And because of that, every high level program, when I say uh, high level programming language or high level language, I mean the human language, the language that we human being can see and understand, can write and understand. But then this high level language will be converted to the low level language, which is the machine code. So in Java or any other programming language like C++, this high level language has to be compiled and converted into the machine language so that machine can understand what we are talking about. Otherwise, machine or the computer will not be able to understand what we always say. So this language that you're seeing on the screen here is compiled. This is written in Java, but a similar kind of thing can be done with C++. So with C++, the language is compiled directly to the machine language because of this argument that I have put here, that each platform of computer has its own machine code or instruction set. Because of that, C++ is compiled separately for each machine. So every time when you write a program in C++ or C, you have to compile it for the specific machine. So for example, if you have the machine that contains Windows, for example, you write a C++, compile it to be compatible with the Windows operating system. Now, if you want to run the same language, the same program on another platform, you have to recompile it again in order for it to be commensurate with the other operating system. For example, for the Mac OS, you need to go and recompile the same program in order to run it there. Now, the same thing if you want to run it on Linux, for example, you need to go and compile it again on Linux and then run it there, simply because of the variation of the machine code instruction set. And that is how C++ and other object-oriented programming languages like C behave. However, when you come to Java, when you write a program in a high-level language, we have Java Development Kit, which allows us to do all this. And inside Java Development Kit, we have Java compiler, we have a lot of executable files. One of it is Java compiler. I don't know the rest. I don't. This is a good catch. If I go inside there, I will be able to see. But just take it like we have different kind of executable files inside the Java development kit. You know, so we have like I can remember we have Java compiler. We have a lot. I wish I had written it somewhere, but I don't like writing things that I don't commit it in my memory. But Yeah, inside Java Development Kit, we have a lot because there are some executable file that will allow us to. I think I can think of something. Like, for example, Java documentation. We have a program called javadoc.exe, which is executable as well. It allows us to create a documentation. And also we have the jar.exe that allows us to package our programs so that we can run them anywhere, like to be, to make our Java program to be distributable, or to be distributed. Like if you're selling your applications, maybe you need to package it in a jar archive if you like. So jar.exe is an archiver. They are all found inside Java Development Kit. So Java Development Kit also contains that compiler, which is Java C. You know, so the compiler actually is the one that helps us to turn this human written language, human or high language, into the bytecode, which is always extended with dot class. So when you compile your Java program, always you will see another file is created with the dot class extension. That, my friend, is the bytecode, which is just done by the compiler, Java compiler, which is found inside the Java Development Kit. So Java Development Kit gives us the environment to write Java program and be able to compile it. Now, when we want to run that Java program, because for us to run Java program, the system or the machine or the computer must understand what we are telling it to do. And the computer cannot understand the human written language in a high level language. Even this bytecode, the computer cannot understand it. That is why Java has what is called JRE, Java Runtime Environment, which comes with what is known as Java Virtual Machine. So this Java Virtual Machine turns the bytecode into the machine code so that the Java program can be interpreted by the machine, can be understood by the machine, and can be run by the machine. So the main interpreter is this one, Java Virtual Machine. It converts the bytecode into the machine code that can be run, by the machine. So any of the platforms that you're seeing here, Linux, Windows, uh, Mac OS, they can now be able to run them because of this compilation that we have done. Java can now be run on any of these machines because of the JVM, which is now the key player there. All these platforms, Mac OS, Linux, Windows, if you like it, or Chrome, because we have about 4 major operating systems nowadays. So each and every one of those operating systems must have Java virtual machine or Java runtime environment on them in order for them to run our Java application. And that, my friend, is, that one is a catch as well, because let us say those machines do not have Java virtual machine in them. Will they be able to run our program? No. So even if we say that Java is a platform independent, yes, it's platform independent because it can be run on any of those platforms, provided that they have the Java virtual machine in them. So if they don't have Java virtual machine, they are not going to run Java application. So we must be able to download Java virtual machine on them if they don't have Java virtual machine by default, because some operating systems are built with Java virtual machine inbuilt in them so that you don't need to install them again. So when you write your Java program, compile it, you can be able to run on any of the operating system. My friend, that's the reason why they say Java is compiled once and run anywhere. It's just because of the Java virtual machine, which allows us to run the compiled version of Java on any platform out there. So we compile it once and run it anywhere, as opposed to compiling uh, it many times, just like as the C++ requires us to do. So my friend, this is the key area when you see that they say that Java is platform independent. You need to know that this bytecode is the one that makes the mysteries of Java to happen, for us to be able to run Java application anywhere after writing it once. So thank you for viewing. I hope this video has been informative, and in the next coming video we are going to look at the structure of Java program or programming language before we download our Java development kit and Java runtime environment in order for us to start our real programming. So thank you for viewing. I'll see you in the next video. My name is once again Samuel Ambrose Onen. I love sharing my knowledge with you. So please give me a thumbs up or down, or you can even report this video if you think I'm not doing the right thing. But all what you're seeing here came from I can recommend for you to go to Oracle website and try to read more about Java programming language. So thank you for viewing. I hope this video has been informative, and I'll see you in the next video. Thank you.